All right. I think it is time, everybody, anybody out there. I see you guys already starting warmed up in chat. Love to see it. You guys can hear me. Hopefully this week I've now failed to turn my microphone on when I kicked off stream. Now in this case, I do have my microphone on. You guys let me know. Do I sound all right out there? Everything going good? Stuart's been missing me. Great, Stuart. I'm sorry that you've been missing. I know I went on a little bit of a flight here, there, and everywhere, and all across the West trainings, and now I'm finally back, at least for this Friday. Next Friday, a little questionable. I know next Wednesday we got some full live content for you. I may have to push that back because, as you guys know, next week is our Fusion boot camp in Minneapolis. So feel free to get signed up as well. Anybody else that is joining us right now, as you guys know, or may not know because you're new here, I am Phil over here at jitcadcam. I'm not only the owner, but I'm also, I believe, the #1 tech because in most days, I'm the only tech it's like. But outside of that, we are here, guys, to give you all the kinds of support when it comes to Autodesk Fusion. That being said, I see Tim out there as well, a little choppy. All right, let's see what we can do here. Why we do this, right? Let's make sure I'm picking up audio on the right microphone. So again, for those of you out there that don't know, this is pretty normal in our live stream. Go ahead and turn up a little bit. Tim, is that any better? Is it cutting out? Is it echoing? Anything like that? Go ahead and let me know. I got my microphone closer to my mouth. Usually I'm a pretty loud guy. I'll give you guys a few seconds. In the meantime, I'm going to go ahead and do the famous crack open an energy drink because, again, you guys don't necessarily have to be our customer. Now, if you're here for the Fusion content, I would highly recommend buying Fusion through us or renewing through us. So if you guys are within 90 days of renewing your Fusion, let us know. But you could also buy me a beer or an energy drink or even a steak at this point. So kicking off another Friday this week, brought to you by Monster. And I think this is the Ultra Blue Hawaiian grape flavor. As you guys know, I have no favorites when it comes to energy drinks, but I'm going to kick this off. Tim sounds like we're good. Jeff says hello. Great to have all of you guys any and every time. Now, I did see right off the rip, Phil with Phil's, going to be wild to me. Phil's production machining out there did ask a question about a Fadal post. Phil, still out there in chat, let me know. I'm going to go ahead and visit that. I don't really have a lot of subjects to cover for you guys, but I do have a couple of things that I am going to put in the video because I've seen this questions or these comments a million times. I don't know what it is. There is a theme to every one of my weeks, and they always come back to 2 or 3 of the same questions from a lot of people. Well, let me get my screen shared here. As you guys can see, we are also super high tech and fancy on my side. Chat is now displayed here on the screen if you guys are trying to follow along. Let me know if you guys like this. I'm always happy to hear of better improvements. As you guys know, my big head from time to time also gets in front of stuff. So what I'm going to do in this case is I'm going to start with what I'm going to call the theme of problems this week. And as you guys are seeing me do, I'm just going to do a very simple box. Go ahead and save this. And where this error comes from is actually get into post-processing. So the reason why, again, as you guys know, I love to do videos because at the end of the day, we can cover things like ticket issues or problems that people are seeing quite a bit of. Now, I'm going to go ahead and throw this on the UMC. This is probably one of the more common machines that I see the error come through on so that you guys can see it's just nothing more than a part on a machine sim. Now, what I am going to do is I'm going to go ahead and throw a very simple path at this. Again, good old 2-fashioned inch face mill, decking that guy off. And now, if I was to go post-process this, and this is where there's a little bit of conflicting time, because for those of us OGs like myself here, as I like to say, I got 40 years of experience, even though I'm only 36 years old. That's because of overtime and weekends. But we're used to a system of having to either select your machine or turn on your accesses here in the post menu. But upon doing so, you're going to notice if I post out this program, I'm going to get a fail. Now, the reason why I'm getting a fail, and this is the pro tip to any of you guys, when you post something and you get errors in the post, 9 times out of 10, you could come down to the section where it states error, and it says you can only select either a machine. You guys saw me select the UMC 750 as my machine, or use the post properties to define the kinematics. Again, I don't know what it was this guys. We had a ton of tickets. I think upwards of 6 or 7 times I was asked about this, whether it be a screenshot or an email. But as you guys can see, the way to remedy that is nothing more than when you go back and repost process, you're going to notice I'm actually going to turn the machine model off. I'm also not defining any of these rotary axes. Now, for some of you, you're probably going to question, why is that still in the post? Well, if it was me and I was running a simple, let's say Haas or even Fadal mill with a axis, 9 times out of 10, you know what you get away with? And you really don't need them, right? So I could quickly just turn on an A axis, and then maybe next week I take the A axis off and I don't need it, instead of having 2 separate machines and builds. We're going to go ahead and hit post. You guys are going to see now we get posted code without any problems. So again, you can notice inside of Fusion, if there's a problem, probably one of my favorite things about Fusion is the fact that it gives you error messages, tells you exactly what's wrong or where it's wrong, right? So as always, guys, I see more of you out there starting to join in. If you guys have questions at any time, feel free to throw them in chat. There's also a support email address down below. You can send over files, questions, put in tickets for problems you're having. So the next problem I'm going to highlight, now this is a bug. This is something that I want to point out that Autodesk, when you watch this video, because I know you guys do, is this is something you guys should probably fix more quickly than not. And this just so happened last week when we were decking off an engine block. But let's say, for example, I'm going to go in and I am going to a fixed size box, and we are going to round up by 0, meaning my work offset, my model top, and my stock are all at 0 right now, right? So in my facing toolpath, however, if I go in and evaluate my toolpath, we could start to have some problems. The problems you're going to see is right now my top height is actually the exact stock top, is also my model top. My feed height should be 200 above that. Now, keep in mind, guys, I don't know if I'm going to be able to replicate this, but we're going to evaluate this from the G-code side of things, see if it does. And this is the only reason we caught this was because the G-code was off. So when I post-process something like this, let's go ahead and take a look here. And as you guys are going to see, we should be at Z0, right? So when we go through our G-code, we're starting at Z.6, Z.2, and then we're coming down to 0. So everything here is actually checking out quite well. However, I'm going to go back and see if I can make this error come through. The problem for some of you out there questioning was the fact that when certain settings were applied here, so again, our top height should actually be, actually, we're correct, stock top to model top, right? And I'm going to pull that G-code back up here real quick, because I want to double verify. Again, we are going to Z0, which is correct. Now, the problem I was getting in this customer is we're actually starting at, instead of, Z.2, we were starting at Z0 and then ending up at Z negative something else. So I'm going to do this one other way. Now, if you guys haven't seen the photos that have been floating around, we actually did everything on those parts based on center line of crank. Now, I am going to, of course, make life easy on everybody, and we are going to plug in whole numbers here, because I want to see, is it going to do it if we change our work offset? In this case, let's go off of bottom center of our part. So again, we're going to regenerate our toolpath, and for those of you that didn't catch it, we should now be at 3 inches at the top of my part. And again, we'll repost this out. We'll take a look at the G-code to see what we come up with. I see Hannibal out there. What's the name of the machine you are using? Which machine are you referring to? Are you referring to my stem file, or are you referring to my computer? What is it that you're looking for there, Hannibal? So again, let's go ahead and validate this G-code. We have our Z position at 3.6, 0.2, and then we are still at Z 3 inches. So it does look like this is remedied, but I have a few other ideas as to why that problem was coming up. Now, again, this points back to the old Phil out there in chat. The big thing is he had a old Fadal machine, and now some of you may or may not know this, but by zeroing out your vertical lead, you don't have that actual arc to start your part. Now, this is where, again, I think we were starting to get into a couple of problems, but as you're going to notice, my green line down here is technically my lead, but since I don't have a vertical lead, let's go ahead and see how the math calculates out. So again, we'll go in, we'll post-process, we'll hit post. Hannibal, the machine I'm using in this case is just a UMC 750 reboot. It's in the default library. Now, I did turn off the enclosure, which is one of the more common things that I get asked. So again, it looks like on my end, I just can't seem to get this thing to force out the problem we were having. But again, the idea is the problem that we had was the fact that actually, I'm going to try one more thing. So again, if our top height and our bottom height are both set to model top, let's see if we can make this happen. So again, we're going to go ahead and post-process. In typical fashion, I should have, at the end of the day, one, not hit no there, but two, just recreated the toolpath from scratch, see if I could get it to trigger the error. And it looks like, man, I'm telling you, either this latest update fixed this bug and it's just bad timing, but if you're having problems when you go in to face something off and the heights just don't seem to be coming out, this is the importance of why you should still, at least at a bare minimum, understand XYZ coordinates as well as some generic G code at the end of the day. Hey, Phil's production machining is back. Very good question that he had there. I have a notification that popped up. Let me go ahead and get that out of the way so my toolbar goes away. So let's pivot gears here real quick. And I'm going to talk a little bit more about the issue that Phil's having. And I'm going to talk about a couple of solutions that'll probably work out quite well. So, Phil, one of the questions I would always have to you is, are you a type 1 or a type 2 Fadal post kind of guy? So I'm going to need that information, but I want to show you an example right here inside of Fusion before we change over to the other post. So as you guys can see here, in the case of the Haas post, it is giving me my G54 before it is positioning me in X, Y, and any of my rotary axes, right? So again, we're not calling a B0 before the work offset. And this is the problem that happens inside of the Fadal post. So again, what I'm going to do is we're going to run a brand new setup here. You need to make this part a little bit more as if we were going to run it on a rotary. We have our Z, we have our X. Of course, we want to rotate around center. And now like that, we can go ahead and steal some tool paths. So for those of you unfamiliar with this move, I'm just doing a copy paste. Now that is Control C, Control V. And just like that, I now have one of my tool paths. So if I duplicate this, I can now create a second version and edit my tool orientation, presumably giving me an A-axis tilt. So again, what I'm going to do is I'm going to go in and I'm going to post-process this. Now, in this case, I want to remove the machine. So let me go back a step. Again, if you had a Fadal machine, you could easily set up that machine using machine definition. You don't necessarily need machine simulation. Now, at the end of the day, I did build out some machine simulation for some people. They are out there on the Fadal actual Facebook groups. Feel free to download them or shoot me an email if you want a copy. So again, we're going to go into the good old-fashioned Fusion library. We're going to look for the Fadal post. And as always, we're going to go ahead and put that in a folder that I will remove later. And this is where we were talking about the idea of A-axis, B-axis, things of that nature. Now, as you notice, I'm not using machine configuration here. So I need to tell the software that I have a rotary table, right? So again, we're going to go ahead and post. And then we're going to evaluate our G code. So as we were talking about, there is an issue with this post, which maybe they fixed it, maybe I'm wrong, is we'll go ahead and try one more thing, which is going to be to do the A90 first. But as you can see right now, by default, we are doing a G4P36, which actually I'm wrong. That is not the correct work offset. We need to go down further. The A0, as discussed, G0A0, which should, can't talk today, man. It's been a wild one. Is what I'm going to want to do is I want to put my A position based on the work offset. But if you look down a little further, right now we are getting G0E1, right? So E1 on a Fadal is work offset 1, but it's being called out after the A location. And this is where the problem resides, is if I was working on G54 or work offset 1 in the controller, well, what will happen is when I go in and I set A0, it thinks A0. It doesn't think work offset A0. So to remedy this, a couple of things you could do is we can edit the post, which we'll come back to. But if you are a type 2 Fadal user, that means your machine will accept generic G code, like the FANUC post processor. So again, as if I go back in to post this, and I actually recommend this a lot for people out there, because if we pick out the generic FANUC post and your machine, for example, has a probe on it, we now have probing incorporated as well. So again, as you guys will see here, we're going to go ahead and double check to make sure we don't have to turn on a rotary axis. So I'm going to turn off G8.2. And then from that, we'll go ahead and post our G code. We are getting a fail. However, as you guys are already seeing, we're getting our 54 between for any A-axis motion. Now, as you're going to see, we need to set up positioning for ABC, right? So as you guys can see, we can, again, this is going to take an post edit, or we can build a machine definition. So as you're going to see, I can do either or. Now, this is where I would recommend to most people. It's very easy to go out and build a machine definition. So what I'm going to do here is I'm going to go to my Fadal folder. Although I still have these machines in there, again, this is why you guys can reach out to us with an email. I'll send them over to you. But if I just hit the plus sign, we're going to do a milling machine. We'll give it a second to load here. Now, from that, if I go to my kinematics tree, I just need to order my accesses, everything as the way they are stacked up, right? So, for example, Z-axis has the milling head on it. Now, on a Fadal, usually your X-axis sits on top of your Y-axis, and then your A-axis is going to sit on top of X. So we'll go in and we'll add a rotary axis. Now, you could set up different things like unlimited, limited, or cyclic. Again, what this controls is, does your machine have a limit from 0 to 360? If it's cyclic, will it output in multiples of 360? Or is it unlimited, meaning you could go to 9 million rotary, right? One additional thing you'll want to do is if you don't have full compensation, so what we're going to do is turn that off as well. And then the neat thing about setting up machine definition is the ability to tie onto it a post processor. So as you guys can see, is I can tie on that Fadal post that we just downloaded. You can also predefine an output folder. Again, this is a great thing if you're dealing with a host machine on the network and you can post directly to the machine, it will auto pull that information as needed. So again, you're going to see my Autodesk generic 3-axis for selecting that machine. Neat thing about this too with machine definition, if there was any problems when we simulate, it would actually notify us that the machine is out of limits, over travels, things of that nature. Now, because there's no model, we don't really need to have the machine turned on. As you guys can see, we've went down, turned, we've machined, and we machined back the other way, of course, like we intended. So let's go ahead and post-process this. Again, I see more and more of you guys all out there. We're going to go ahead and turn off has rotary table, because I believe if we leave that on, we'll get an error message again, and we can repost that. Now, I know some of you are probably questioning why I keep posting with when I need to post with the FANUC post, right? So again, I'm just showing you guys a little different technique to get this all set up. Well, we can go back and edit that machine and pick a different post processor. So let's go ahead and swap out, as our original goal is to jump to a FANUC post. Now, the reason why I'm picking this one, it's a second version in this folder. It is the latest and greatest, as you guys can see. So there is no edits done, as this post still needs to be updated, right? So again, something great that Autodesk did do is fix the fact that it doesn't automatically force updates on your post processors. So if you do have those edited posts, they should retain their edits. So you choose to set them up at the end of the day. So again, I know this is a lot. We did a lot here to get all the way to the point that I could post out with an A axis after G54. But this is also why I tell most people is if you're using a Fadal machine and you're doing type 2, it will accept G54 code as well as a lot of the other side stuff inside this post. Now, to make post changes so that the A axis spits out, well, that the work offset is called prior to, you can walk down that way as well. So, Mad Campers, I see you out there. Maybe my brain's not working. Custom drill cycles work. We'll go ahead and take a look at that here in a moment. But as you guys can see, we can go back. Once again, we're just going to remove the machine. Maybe I don't want to set up machine quite yet in my life. I'm going to switch back to the Fadal post, and then we can edit it. Now, in order to make edits to the post, there's a couple of things you'll have to do. For example, is where it has in here as rotary axis, we're going to go ahead and set that from false to true. That way we can actually hit code with an A-axis outputted. And then from there, if you guys don't have it, I highly recommend installing the Fusion plugin because it's going to allow you to generate simple debugging code. And we're going to go milling 3+2. And now I would like an A-axis motion toolpath. And just like that, you guys can see here is my A-axis callout. Here is my actual A motion. So if I double click, you're going to see there's an area where it's going to force XYZ. It's going to force my A-axis reset. Again, my next line is literally turn on tool coolant. And if I go down one more, you have that ability to now do your right initial position, right? So again, we're going to initial position. Now, if I know what line of code I want, we can go ahead and copy and paste that line of code, right? So what I'm going to do here is control copy. To go down a little further, I'm going to paste that in and hit save. Now, in this case, nothing has happened. So sometimes you have things that are modal that'll stay on. And we're going to go ahead and double backslash to get rid of that. And now, as you're seeing, I do not have my A-axis motion being called out at all. And with that being said, is if I undo this real quick and hit save, you're noticing that it's up here at the top. But upon redoing so, it has now placed it down underneath everything. So as you're seeing, we are going to an XY position, our tool length. We're going to a home position in Z. We're then calling out our A-axis orientate position. And then from that, we're starting to run our G code. Now, this is a little dangerous, and I say that because you are moving your A-axis after you have done a tool length compensation. So your right now is down by your part. I just want to make people aware of this. Also clears up a lot of things like able to utilize your clearance height of your tool path that you don't go home every single time. So something that might be a little better in edits is I'm going to go ahead and undo these couple of things. And hit save again. Now I can go to that E1 line, right? What that is called out is WCS code. So as you can see is that WCS code is what needs to be called out either in that same line or in a separate line all by itself. And we'll copy that code. We'll go back over here to the 0 line. Now, based on what your settings are and the way you have everything set up, you may or may not be able to just simply a right block, punch in that WCS code, and then we're going to hit that with an end of block and hit save. And just as simple as that, we've now one appear before the G0 A negative position, right? Or A positive or whatever your initial A is. So again, nothing more than this line of code, Phil. I'm going to throw this in chat for you guys just in case you want to copy it out and utilize it. but all I did was place that right before my initial G0 call out. But again, my personal opinion for a lot of you, if you're on a Fidel machine, I would just use Panic Post Processor. Well, I would do the type 2 setup on that machine. If you don't know about that, send us an email and we'll get you all taken care of. Again, I'm not seeing a ton of questions out in chat other than the custom drill cycles. So with that, we can go ahead and pivot. Thinking about getting a 3D printer, any tips you might have for making a print-friendly model? Always. I have tons of things about that, Tim. We'll go ahead and visit that here in a moment. Now, Tim, I do have to ask, did you buy a 3D printer already, or which ones are you looking at as well? So as you guys can see, we're going to go ahead and close out this post-processor side of things. We're going to shift gears here a little bit. Now, I am going to pop a hole in my part that we can create a drilling cycle. And we're going to jump back into the manufacturer side of things. Go ahead and regenerate these paths. And the question that was asked by Ads Camper, we're going to go ahead and swap out and try to do a custom drilling cycle. Now, the reason why I say try to do it is because it's one of the few things I rarely get asked, but I usually forget what we have to do in order to make it happen. And for those of you that know, what he's asking about is why is there a little box for custom, right? Now, depending on what you're doing inside of Fusion and what you're trying to achieve, if there is something, for example, let's say you were trying to do a backside counterbore, right? Is we can set up a custom cycle that you can utilize when you post-process. Now, the problem will be is if I post-process, believe I'm going to get an error, especially. Give her a sec here because it's missing the logic inside of the post, right? As you guys are going to see, cycle custom is not supported. But the good news is we can look inside the post-process for drilling cycles, right? So again, I need to modify the post-processor. Now, from that, click in our little pencil to edit. And as you guys are going to see, I'm going to type in cycle. Now, there is a lot of cycles inside of this area. So if I go backwards through my list, you're going to notice I'm doing a lot of clicking to try to find this. Now, if you look for something like maybe drill, as you're going to see here, that's 1 of 15, right? So again, if I scroll down a little bit, you start to see where there's different areas and different callouts. Now, again, this is the luxury of the debugger, guys, because once again, if you pulled out CNC selector milling, there is a section for drilling in here. If I remember, that's mill turn. Milling. Make this a little bigger for you guys to see. Let's go ahead and get that expanded out. There we go. What we're looking for is, let's say, duty. Nothing in there because drilling is its own section, and we're just going to do chip breaking, right? So again, as you guys can see, I have a drilling cycle. Now, maybe we swap that out because a keep drilling, as you're seeing, we're not getting a actual cycle put out. We may have to modify that to find it. But the idea is if I click this a few times, I'm going to eventually find the area where it either says write drill cycle, which this is the fun of computer language. So I can actually F find that. And as you're seeing, there is a function called write drill cycles. Now, the reason why this is so important is because what you now see is which different types of cycles, right? Cycle type. You have drilling. And as some of you are going to start to notice, you now have counter boring. You have chip breaking. Anybody have an idea as to what that is referencing, right? So again, this is the cycle you're picking inside of Fusion. Presumably, what you're going to have to do, again, you have your tappings and everything, is we are going to have to set up a case. So in this case, for the case, right? We got cases on cases like it's Counter-Strike. So we're going to go ahead and copy. And then what you're going to need to do is you're going to have to plug in basically that, let me undo that here. We need to highlight everything from the case to the break. Go ahead and make ourselves a new row, paste that in. Now, what you're going to want to plug in is custom, right? And just at the simplest level, we're going to go ahead and hit save because we're going to go back inside of Fusion and repost to make sure that it's properly. So again, let's go ahead and close this out. Let me jump back to Fusion and hit post one more time. As you see, we now have a successfully posted custom cycle. And from here, I'm not going to continue too far down the rabbit hole. But as you guys can see, if you have a lot of different codes or different ways you want to call stuff out, you can do that all now inside of our custom drill cycle, right? Let me get back over to chat here. It seems like you guys are getting a little rowdy out there. So again, as you guys saw, I went ahead and plugged in that case custom. I'll throw this in chat too, just to make life easy out there for Mads Camper. If you want to, I don't know, can you guys copy stuff out of chat that I put in there? Oh, it's too big. I can't put the whole thing in there, but I think you guys are, all I had to do was, again, duplicate one of the cases and then, again, change it to custom. And from there, I was able to output whatever I wanted. So, again, we're going to go up. Let's see here. Hey, Phil sent in a ticket. Awesome, Jeff. We'll jump on that. Stewart's got an email. Of course, now you guys are popping off, right? All these things out there. There's a code on, or there's code online for bed leveling. It saves on the time and effort. Awesome. So I'm going to tell you right now, Tim, just like you said there, Bamboo Labs, I hate to say it, being a reality fanboy for you. I have a Bamboo Labs. I actually have two of them. I love those machines. They are amazing. It is the only machine I have ever found that I could just send stuff to it. It comes out perfect every time. I've never tweaked it. I've never messed with it. I've never souped it up. I just send stuff over. So I recommend to most people, Bamboo Labs, amazing printer worth every penny. So as we're going to go down a little further, in Tim's case, he did have a question kind of more around the idea of tips for 3D printing. Now, keep in mind, guys, you can do 3D printing inside of Fusion and slicing. And it's kind of neat, and a lot of people overlook this, but again, back to my Creality fanboy days, is if you go in and you look at the additive section, in this case, we need to go down to the default library. You're going to notice there's a million different printers in here, and you can search because there is Bamboo Labs slicers here, as well as Creality and any other type of machine you're going to buy. But the idea here, and this is where we're kind of starting to this all from the start, is I need to select a machine in this case for 3D printing. Now, as you guys can see, we're doing additive. I can also select my print settings. This is going to be different PLA settings, how you're going to print, speeds, layer heights, fully editable, fully changeable, and you can make as many as you like. Now, the bad news is, out of the box in Fusion's world, they don't have the ease of use like in this case, Bamboo Labs' software does, but still the same workflow, right? So again, there's my part. Give her a second to load. Now it's asking me where to put it. How do I want to arrange it? How do I want to place it? So forth and so on. And then it would be as simple as here, generating supports. So again, we could do either a bar support or bases, solid volume, a lot of different ways you could set this up. And one big thing you're going to notice in the world of Fusion, again, this is why I love Fusion's use case. Go ahead and click the entire model here. We're going to go ahead and undo and redo that. So again, let's go over, where is our model? There we go. We can actually define different supports to individual item, and you can set up a cube, and you could basically print 100 different things in here all at once. But we're going to just very basic level supports. As you guys can see, this is supports it's going to put inside of our bore. And then from there, we go ahead and generate our actual slicing, which is what I'm doing here. And then we can simulate the slicing. So some of the tips I would have for Tim, these are good tips I've picked up over the years, is the ability and the angle at which you print or design something, right? As you guys can see, is this is requiring supports because of something like where do supports need to go based on overhang, right? Now, if I was to print this part at more of a 45-degree angle, knowing that I don't need supports all the way up inside that bore, I only need some of the supports on the outside of my part. This is where everything and anything changes in the world of Fusion or anybody that's going to print, right? So again, in this case, we have our supports. We need to go through and make sure that we are going all the way down to the base, which I can't remember how to do that, but we will go back to the top. Base solid plate. Let's go ahead and select our model. Now we have a solid base. I think you can reorder these. I might be wrong. They have done so much to this thing that it's been I honestly, I'm trying to remember the last time I used the slicer, but the power there is insane, right? So as you guys can see, we went ahead, we sliced up our plate. We would have to generate our slicing, go to the, in my case, like I said, is I've done a ton of 3D printing, and I will tell you, stuff like this, the orientation is almost the thing that you need to think about. So when I design a part for 3D printing, I use the traditional designing method of like, how would I machine this in a 3-axis environment? And that usually helps me run with my model prep and how I would make something to go out and be printed, right? I'm also a big fan of always trying to play the game of how can I design this so I don't have to put supports on, right? Supports take time. That would be my recommendations to get you started. So enders are good. Yep. I mean, by all means, I know in Tim's case, he's got a whole shop over there that he's got no problem getting a Bamboo Labs for sure. But I'm hands down, the Bamboo Labs machine are. So with that, I see, let's go ahead and get up here. I did see a couple of emails come in, and I'm seeing Hannibal. Can you show us how to download the Haas UMC 750? Yeah, so Hannibal, it's actually really easy. So by default, when you go to select your machine, you don't have to actually download anything. You just need to scroll down here on the left. Go ahead and minimize some stuff. All the way to the Fusion library. And inside this library, you can search by Haas machines. As you'll see here, there is every and any kind of Haas machine along the way. Pick the machine you want. It'll ask you to copy it and save the file, and then you'll be good to go. So give me a few seconds here, guys. I'm going to go ahead and jump over and grab some emails real quick. Go ahead and back down here. All right, let's start with Jeff. Toolpath on the final operation is doing weird things after the main cut. Can you explain why? Oh, man. Always fun time, isn't it, guys? So what I'm going to do is we're going to go ahead and upload this file here real quick. And I'm going to jump over to my emails. It looks like somebody placed an order for $45 of beer. You are a champion. Thanks, Phil, for that. Those will be enjoyed quite well. All right. And Stuart with the how do I fix this? Or how do you? All right, let's see what you got going. We will come back to Stuart's here since I've seen that upload here quick. All righty. So I got to shift gears because I got one in an email and one in the support ticket area. Okay. Toolpath on the final operation is doing weird things after the main cut. So last operation, this what you're referring to. Jeff, let me know. I got to pull back up chat so I can make sure that I'm seeing what. We'll give that a few seconds, guys. In the meantime, as Phil has already done, if you guys want to support our channel, I've said it a few times. I say it every time. Feel free. Up on our website. You can use the link down below. You could buy me beers and steaks if you guys learned something. You could buy Autodesk from us. Support packages that would cover all these edits that Phil was wanting me to go through, as well as a lot of the other edits like our custom cycles drilling. But what fun is if I don't allow you guys to go out and mess up the post, then you got to buy support, right? So let's see here, Jeff. Yep, that's it. So what Jeff is referring to is all of the shenanigans on the outside of his part. So all these little bitty extra lines. Now, I'm a firm believer that one, Jeff, did you have the bug in Fusion where it opened up everything? Let's go ahead and collapse all these down here real quick. You can actually do them all in one shot, which is really nice. And then just open up the individual one. You guys can't see it. That's good. Let's go ahead and get that screen. It's another Friday. This is why you guys buy me beer. I come here, I pick the wrong screen, I get stressed out, and then I got to drink, right? So As you guys can see here, the problem that I saw right off the rip, Jeff will have to let us know. He actually didn't have the bug of all these out expanded. I do know at this point they have fixed the bug, but you guys can simply collapse all children and then just expand out back to the couple that you need. So, a few things I'm going to evaluate. Also, Joe, great to see you in chat. Is how are you setting your boundary, right? Because in the process of fusion, it looks fine. We're not doing multi-axis. The next thing is geometry. So if I look down from the top on this part, right, a few things are happening. Is one, he seems to be going much further past than this cone that he's looking for. He's also waterfalling on the outside of his part. Now, the reason for that at the end of the day is he is using a spiral toolpath, so he wants to whip around this thing. But he is also using a silhouette of the part. So a silhouette is taking into account the entire outside profile that he's trying to machine. Now, if I had to make a guess here, he is also utilizing a bottom height face to stop the toolpath from going too far down, right? So a couple of things we can do, and I'm going to start a brand new toolpath to show you guys how I would think about doing this, is first and foremost, let's pick a toolpath, any toolpath whatsoever. I think you will be very satisfied with the ramp toolpath versus circular. Okay. Now, from that, we're going to utilize this same exact tool, and I always use the system of just hit OK, right? Upon hitting OK, I have quite a craziness of items going on here. And we're going to have to evaluate why is this being so hectic. So let's go to our geometry tab. So again, by default, we're utilizing a silhouette of that part profile. Now, we are ramping down. I should remember that we are ramping down. So I'm going to change gears here real quick because it'll be easier to understand if we actually do a 3D contour first. And of course, we're getting even more fun results because each one of these has different settings. So let's just say, for example, we're using 3D contour. Let's take tool outside of boundary. As you guys can see, we're going all the way around the outside, all the way to the bottom, right? Same thing was happening with ramp, but the reason why this is a little ugly is because our ramp has an actual helical ramp height start way above our part, right? So again, what you're seeing here is we have a ramp clearance height of 3 inches, which is massive at the end of the day. So if we were to change this back to 0.1 and nothing has changed, which really leads me to believe that it's me, not the software, but we're going to go ahead and do what I think is actually going to remedy this long before. I'm going to be using a selected boundary. And the reason for that is because if I define my upper and lower boundary area, and our tool is based on center, and we're using contact point boundary, which means shift over the tool to where the tool actually touches those edges, we're going to get a good result around that area. Now, in this case, we're getting no result on ramp, which leads me to believe that there's something else going on. So let's go back and try our contour toolpath with the same technique. Selected boundaries, top and bottom. Again, we're going to do contact point boundary based on center. So again, we're getting no result one more time, and I'm starting to believe that that tool might be too large, or we might have a problem in our setup. So let's double check our setup. We have stock from preceding continuous rest machining. We have rest machining on our toolpaths causing problems. Not. So let's go with the standard. Let's make the tool go even further out. So again, we are getting quite a lot of problems from this tool running around the outside of this part. So this is where we have to start to decide, is it a tool problem? Is it what I'm defining? Let's go back and try one other thing, which might be as simple as let's remove the inside boundary, right? Keep the outside boundary, tool center. Let's get contact point boundary off as well. Now we are getting a toolpath. So we're getting somewhere slowly. We're probably going to want some much smaller step downs. And now, as you're seeing, we're at least starting to get a toolpath on the part. Now, the contact only is a big element here, which means we're now doing both inside and outside. But again, the fun of this is always get the blue lines on your part, because once you get the blue lines on the part, you'll notice that you get a lot more done in a short period of time. So again, going back to ramp, let's go ahead and do tool outside a boundary. Let's go ahead and remove this upper boundary. That was not it. There, whoop, we're going to go ahead and undo that. There's our bottom boundary. And again, we're getting all kinds of hecticness because of our step down being the problem more than anything. Again, let's say we're going to do 10,000 step downs. One. Now, I like the ramp toolpath. As you guys are seeing, where I'm getting the ramp toolpath looks great. And we're getting a lot of extra problems here. But we can simply remedy that again, maybe by tool center on boundary. And just like that, we've actually gotten a very, very clean result, which I guess, Jeff, you're going to have to let me know. Is this going to work better than what you kind of had going on here? Because I would also say you're getting some of this hecticness, again, because you're still contained by a silhouette, utilizing things like contact point boundary, but then the tool path is still trying to make it down to the surface. Never gave it boundary to start with. For example, I did a selected boundary, right? And tool center. As you can see, even in your tool path, by utilizing selected boundary, remedied the issue, right? So again, this is just my take on it. Now, I would go one step further. We're machining at the top of this part, which is a big waste of time. We might now actually add that second boundary up top. And as you can see, I've now got that cone profile. The tool's not touching the top. We're not wasting cycle time. Same thing with our ramp here. And difference between ramp and spiral. Ramp works on a step down. Spiral works on a outwards spiraling motion, as in step over. Jeff, does this clear things up for you? Now, on the other end of the spectrum, I'm going to go ahead and shift gears here. Let's get back to the email we got from Stuart. So, Stuart, let me do this. I'm going to download these photos that I can pull them up on my other screen. And then we can take a look at it. Give me a sec here, guys. And this, we have all three, right? Yep. So, maybe I can get these in a little better view angle. One, there's two, and then there's... So the question is, at the end of the day, is created a sketch on top of a surface of the below part. It then has this ghosting blue that gets in the way. Eventually, in manufacturing, I try to pick, I get bound by offsetting plane 0.01, and then so the problem that is happening is upon creating your sketch on a surface, I'll use a good example here. Say I want to create a sketch on this surface. In design, I create a sketch on a plane, and then I'm going to hit finish. But what this allows me to show you guys, it narrowed back down, is that exact sketch that you created, it automatically projected that surface that you were sketching on, as well as the edges of the geometry. Perfect. So let me go ahead and get OBS pulled back up so I can see you guys. So as you can see, by default, it's automatically there. Now, I do see this a lot when you're in the manufacturer workspace, for example, is if you're trying to pick something and you have a sketch turned on that has a projected surface, you can't pick what's behind it. And a good example of this is if I get the model turned back on. But it looks like the model doesn't want to turn on, so we'll manually. There we go. But let's say, for example, for some reason, I want to grab the surface behind this, right? I want to grab this surface back here. But I can't do that because the moment I go to this surface, I'm picking that actual sketch plane that's turned on. Now, a trick to this is if you're not wanting to turn that sketch off for any reason, you can actually click and hold on a surface. And as you can see, I now have the profile or the face or the third face based on the view. So one quick way to reach through a sketch, this will be another reason why I'll show you this. Right here is that sketch we created, but I want to grab that edge. So if I put my mouse on the edge and I left click and hold, now you can see I can grab that edge through what's going on, right? So again, super neat trick if you have to keep that sketch on. Now, a few other things you can do is in your preferences, if I remember correctly, there should be a setting that automatically either projects the edges or does not. Now, I might be a liar. So there's actually auto project geometry on an active sketch plane. This guy right here is probably what you're going to want to turn off. Again, you have show ghosted, body converted. Well, you don't want that guy. But again, auto project geometry on an active sketch plane. Another one that you have the ability to turn off for any of you guys out there when you draw something and turn it into a model and your sketch turns off and you lose your sketch, you can actually turn off the auto hide sketch feature. If we go ahead and kick this off real quick, I just want to take a look. Let's say we go ahead and create a sketch on this plane. As you guys can see, I don't have that blue hue there anymore, right? And if I turn off the body, there's nothing there whatsoever. Wireframe can help as well, as Hannibal is saying. However, if you put in a support ticket to me and you have wireframe turned on when we do a screen share, I'll probably nicely leave that meeting. It drives me mad. No offense, Hannibal. But again, as we are seeing here, go ahead and get back to that email. As Stuart was requesting, I just created a sketch on a face of a body. However, it never projected the geometry of the body, right? So again, the body is still there. I have my sketch plane that's already been generated, but by turning off in my preferences, auto project geometry on active sketch plane, it no longer gives you that blue ghost of that face you selected, right? So again, you can turn that off. Same thing with the auto hide sketch on features. As you guys have seen before in the past, I'm a big fan of rectangles. They do a lot of damage quick, but let's say, for example, you're making an L bracket and I extrude this, but you're going to notice upon hitting OK, that sketch right now did not turn back off. It left the sketch on to be reused time and time again, and then I would have to go turn off my sketch. Or a really good workflow is you can actually right-click and show all or show and hide all of your sketches in one shot as well. So if that is a nuisance, very easy to change those preferences. Again, I'm seeing more and more people show up and disappear in chat right now. If you guys have any questions, feel free to throw them in chat. I'm here for all of you to help in any way and every way I can. I feel like we've been going for a hot minute here. How long we've been going? We're an hour into this. Chat slowed down. Few people left. A few people have showed up. Any other questions, guys? Anything else out there for you guys? Stuart with a thanks in chat. I appreciate it, Stuart, as you guys saw. Once again, some of the things that people have complaints about in Fusion are as easy as changing their settings. Now, I have dealt with a lot of people lately that have been doing stuff so wrong it's made my life easy, because I know all of you have realized we have switched the hub system over. There's a million things that I've seen people do right and wrong. If you guys need help with your Fusion hub, feel free to reach out to us. We're here to help you guys in any way we can. Let me go ahead and check the ticket system again. You see, I have emails directly. That was the beer from Phil. That's good. A meeting reminder I'm not going to make it to. And then on the ticket side of things, we can actually talk about that ticket. And that with all any other questions at this time. Little manual fourth axis on here. What is this? Picture it. Don't know where this ticket just came from. Is this one of you guys out there in chat right now? Or is this somebody else? I'm so confused. Actually, I'm not confused. I partially know what that is. Let me get back to chat here, guys. Give me 1 second here. I'm going to go ahead and that when he goes to renew his support package, like, look at all this stuff you guys have set up. So converting a mesh body to a solid is a little for me to show it. It does take a lot of process power. If you have a copy of a file that you want to send over, my way. Get back there. I'm kind of confused by that. Oh, or did that one work? That is no. You guys tell me in chat. Somebody send me a ticket. Staying quiet at the border? I'm losing. That's very possible. And one of those weeks. Ah, okay. Jeff, are you out there sending me a million different different email addresses? That's what's going on here. Jeff, how do you have so many email addresses tied to you? Jump back. That is a good question, Stuart. I really like that question. I have a video on it, but I can show you guys. So let's say, for example, I am going to use the lovely UM7 because it's a little easier. I know how it's going to be, probably very unpredictable always. But the question was, how do you go about? Why is my model already? Hey, I think when we did the move, boogered this guy up. I'd have to do fashion. So the question is let's say, for example, you don't have Cycle 800. There's a million names for it, right? I think it's Cycle 88 for Okuma. Basically, what that is we're allowing the computer to do the math from your work offset. In this case, we're going to go ahead and throw our work offset up top. Again, I don't know what happened. I might have jumped. Go back to design and move now. Fun. It's always fun. This story of my life when it comes time for us to do 360 type stuff. And as you guys are seeing here, I have somehow broke my fuse where my stock is not actually getting to go near my part. A mile away. You guys see? New bug. We've logged a new bug. Jeff with the what sign out in chat. So as you guys can see, when I broke this part, so we're going to have to go to a different part, make life a little bit easier. Let's go ahead and pick on this part, right? Easier part, but it'll work great for our setup and everything inside of Fusion. I'm curious as to what is on here that I am not getting my synchronization to happen. Yeah, we're going to ignore that for now. I think I broke something, guys. For some reason, nothing wants to. As you can see here, here's a part that we would put on maybe a UMC7. Go ahead and go back to the old fixed size box. And my work offset would probably be top center of my part, just making my life easy. I am going to have to drive this body. Now, this is why we tell you guys do not do stuff as bodies, do stuff as components. Will make your life much easier in the long run of things. So, let's put our part on the UMC. In case we'll go ahead and junk up one of mine. I'm really good at tearing guys up. And now, what the question is what happens when your machine doesn't have dynamic work on? You guys are going to see this here because I want to give you a good example of why you would want the option versus why you wouldn't have the option, right? So going in and machining this part, I don't think you have any rotary tilting. That is, we'll go ahead and duplicate. Let's do something on the angle here. Might have just broke. We'll give it a sec to think about what it needs. Let's see. Is it gonna happen? It happened. There it is. I've been really good at this for a while now, without actually having any problem. Give me a sec here. We're gonna go ahead and send this off to Autodesk. This is very valuable for a lot of you guys out there. I've seen this. You guys crash Fusion and you don't send it error report, and that is going to be a big deal at the end of the day. So again, we're going to go ahead and pop open 60. Give it a few minutes to load. Anybody else have any other questions out there in the meantime? I do. Jeff asked what at some point, so still kind of curious as to what he's talking about. But we're going to go ahead and set up a machine as if it doesn't have dynamic work on it. So again, let's go ahead and get that file all popped back open. I think what I'm going to do to ensure success here, I am going to dump all of these setups. Maybe. I have now lost my middle mouse button. There we go. There we go. She took a second to come through. Let's go ahead and delete all these. And let's do this the right way. Let's start with our design. Want these guys to be components. Makes life much easier. And then on the manufacturer side of things, let's go ahead and run it down through the top. So again, our setup, doing milling, the axis up is always nice. My model itself is going to come from our component or our level foot. Our fixture is the component. And just like that, we at least now have a good setup. And let's get some paths on. Again, we're going to go ahead and face this off. Okay, we're going to use Gates end mill. And I am going to do a tool orientation. Give it a second facing operation, right? So in a perfect world, spent the money, you bought the machine, and you failed to get the actual dynamic work offset or tilted plane, which what that is I was trying to show you guys here. Get back on that Haas, is it is the machine capability of calculating where your work offset is in reference to your axis of rotation, right? So think about it. There is a B axis on this that runs across, and then there's the C axis around the table. Now, those 2 points are going to intersect right about here. But with dynamic work offset or your tilted work planes, again, there's a million names for you guys, is it will know and do the math to wherever you probe your. Now, if you don't have that option, what we need to do is we need to define it in separate locations, right? So what I'm going to do here is I'm going to go back to design. And the first thing I always like to do, I would have put this part in my machine. I would have probed it and I would have known where it's at. So I like to set up and do a joint origin, in this case, from my part, basically where that center of rotation is, right? So I'm utilizing a joint origin to generate the distance to my part from center of rotation. As you guys can see, I now have that as a reference point. So with that, on the manufacturer side of things, that is what I'm going to use as my work offset location, right? So again, we go back into Fusion. I can use a selected point. That is going to be where my work offset comes from. Again, all of my G code from center of rotation, where my part lies, right? Now, the bad news is doing this, if I wanted to get machine sim to work properly, you're going to notice I can't easily align that joint origin, center of rotation. So this is where I need to edit my machine sim to make this happen and work the proper way. So this is where I'm going to go into my machine library. I'm going to go to that machine and edit in Machine Builder. Now, as you guys can see inside of Machine Builder, we can jump over to the design side of things. I'm going to go ahead and get the static base off. Now, in the case of this machine, there's probably a lot of ways to pull this. Easy enough in the model, I can inspect from the flat up to the center of the cylinder, which is my center of rotation. That gives me a distance of 50.8. So again, I'm clicking that to copy. Now I can place a origin, in this case, on my table. I could bring it up, in this case, negative at 50.8. So in a perfect world now, this joint origin sits in the center of B. As well, from a top view, it sits in the center of C. So between those two items, that is what I'm going to utilize when it comes time to actually set up and run my machine simulation. Again, you're going to see me hit finish machine builder. It's going to take a second to save this to the cloud. Close that out. And then what I want to do is make sure that we bring that back inside of this file. And we're going to go ahead and remove that from my setup. Then I'm going to go back into my setup and select it. As you're going to see is it's going to tell me I cannot load the machine model. And the reason for that is if we go to document, it currently thinks that's a part of this document. We're going to go ahead and delete that. Then we're going to go down and pick that machine. And you're going to see this brought in. We can now do our positioning. Give her a second to load here. And as you can see, I now have the joint origin of my part and the joint origin of my center of rotation. So what I need to do is now just do a selected point. I can pick point 1, point 2, and then of course we don't want any compensation in here. That's still going to be 0. But just like that, I have now set up both the machine stem as well as the joint origin of my part to give me the distance of my stock or model from center of rotation. And that is basically how you treat the entire system. Place your part so that it is referenced to center of rotation. Now, we can move this part or this model at any time simply by going back to design, editing our joint origin, of course. Maybe it's closer this way. Maybe it sticks higher up. Maybe it's more back to center. It's not far off of center. But as you're going to see, all of my adjustments for my part now come from the joint origin. And this is also why, if you guys check out my content, we build out vices. We do all this additional stuff to make life easy. Parametric stock would be amazing here because then you could just adjust everything in parametric, in the parameter window versus manually as you guys are seeing me adjusting. But down and dirty wise, it readjusted everything. We generate all of our G code. For to machine sim this right now, you'll see that all of my code is coming from center of rotation where I would set that work, right? So again, machine turned on, come in. You guys didn't know, this is a cool thing also with machine sim is we could actually look at the G code in real time. As you guys can see, depending on what we're going for is my first couple of Z-axis motions. Get down here far enough. That Z 2 inches right there is from center of rotation, right? So again, when you run through this G code, it's a little easier to see if we get back towards the top. Again, you're going to see Z is 8 inches above the center of rotation. Come in and machine that, back out, rotate around, and then come back in. So I hope as a whole, Stuart, does that answer your question? As well, if anybody else has any questions, feel free to ask them in chat. I'm here for you guys. I'm always happy to do anything I can, at least in this live stream, set you guys up for success. And if you're watching this live stream at a later date, which is shocking to me, that, for example, I'm not going to brag about this. It's nothing fancy, but being the fact that we had 80 views right now on this video live, by Monday, we'll have almost 400 views. Feel free at any time, go ahead and send us a support ticket down in the email below, or send us an email so that we can help you out or at least prep this next week. So I see a few more questions. Jeff out there. Can you do this with the manual 4th axis as shown in the email I sent you? I'll go ahead and verify that email. I was curious what the status was of it. Can you chamfer a pipe at the end that is milled at 20 degrees with a lollipop mill without cam extension? So presumably, Mads, it's going to be hard to do. There's going to be a lot of math there. I would highly recommend just getting the extension to use the deburr tool. Now, you can buy cloud credits. You can pay per month. There's a lot of different combinations on that. Mads, you also have the ability to turn that on for, I think, 10 to 14 days. Joe, did you show the code? Joe. Where'd Stuart go? So let me go ahead and grab these photos real quick of Jeff. Not photos of Jeff, but photos that Jeff sent in. Go ahead and pull these down here real quick. Get them all pop back over, guys. Start having photos. All right. So annual fourth axis, right? I gotta try to mentally figure out these photos. If you guys are talking in chat, give me a moment here. I see what you're doing. Okay. So you're utilizing the quick vice system to get everything set up and dialed in, right? So like a 0 point fixture program. Talking about. Again, I don't have my chat pulled up right now, guys. A hot minute. Is there a fast way to do this? Right. Boom. Go. Here we go. Be fancy now. Watch yourself, guys. So, as we can see here, is basically with the quick change system, you are utilizing more or less a 0 point. Correct. Go ahead and let me know. Let me go ahead and flip back. Oh, how did I show the code? Yeah, I'll pull that up here. So basically what's happening, and the problem you're going to have, Jeff, at the end of the day is, although you're using a 0 point, is how accurate is that part in the vice? However, there's a lot of neat things you could do. Because I did the photo here. I might have to pull it up. So from operation 1, all of your vices are being attached, either connected or disconnected based on 4 lugs, and you know the exact center point of that vice, if I'm correct. So doing so, all of your G code could come from this actual dual action vice or this self-centering vice, right? I don't know if I have a self-centering vice in my library. Give me a quick second here, but I am going to hit you up, Stuart. Stuart, real quick is give me a few moments. Like, you guys got a bunch of questions in here all of a sudden. So how did I show the code? So very easy. I went up to the top under information, NC code, and just like that in real time, you actually have the code to be able to evaluate. That's going to be posted. Now you do need the machine definition set up. The post tied to the machine. You have to have the actual simulation model. Again, this is where we come into this whole thing. If you have all that info, we can help you get that going. But from that is simulation running actual G code like backplotting. So the bad news is Tim, this is not a G code simulator. However, what is happening on screen more or less controlled by the post and translated into the G code. So what you see on screen is more or less what the G code should be putting out. Now, I say that vaguely because a lot of out of the box solutions will need a couple of edits. Again, axis of rotations, limitations, things like that. But say the least for anybody out there, if I hit play here, as you notice, is this as a whole is actually showing you the G code that Fusion is expected to generate upon post process, right? I just want to make that clear. This is not a G code simulation in any way, but this is the NC code that you are to expect to come out of that post process. So let's go ahead and turn around and get back to the 0 point system. Now, I'm trying to think if I have. I don't think I do in my system. I have a dovetail vice. I do have a dovetail stock. DM. This will actually work out better than we're lucky today. We're having problems. We're making solutions. So, visiting the idea of setting up a 0 point system, right? So as you can see, this is again a part of a quick base system. So that being said, what I would do is I would start simply by adding, not a joint, but I could set up a joint origin right off the bottom of this part. Now keep in mind, in this case, and in this exact solution, is we are utilizing linked components. So just keep that in mind. Again, when we talk about setting up our parameter vices, all of this stuff is linked. So I may want to actually break the link so that we don't change the external files. And with that, I can now place my joint origin based on the bottom center of my part. Again, what that allows me to utilize is basically any fixture this now goes into, all of my work offsets are going to be driven by this joint origin. So if we quickly swap over to manufacture, clear everything out of this part that's just sitting here waiting. Now you're going to see me go through and utilize components, key element, guys, components. So again, we have our clamp base. In this case, I think the part is actually missing. So we're just going to claim the stock is the part. Our fixture is then the clamp and the base. And then my Z orientation, of course, we're going to go ahead and bottom of the part, flip it upwards. X might run along the part, so let's go ahead and get that defined. And then the location is selected on the origin, right? So again, work offset number 1, bottom center of my plate. My next work offset, as per the photos, I don't think I'm going to be able to cleanly pull these all up. There we go. So that would be setup 1 right here, right? So now with setup 1, you would have to, of course, probe that on your machine and find where that it's at. Now getting into setup 2 in this top left corner, or setup 3, presumably in the bottom right corner, we're now moving through the stages of what we've machined, right? So again, I could still use the same location. I'm going to have to find it on this known fixture, but it's still the same concept at the end of the day is going into setup number 2. Again, to play the game, I want to choose Z is now maybe this way. My X location is going to run down the part. I'm going to flip that. My location for my work offset is going to go back here. And just like that, we would then again pick our model. We would then define our fixture. And we're now going into our second setup, still using a 0-point location. Now, keep in mind setup 2. This might be, work offset 55. And then from that, we would do that one more time. I'm just going to duplicate my entire setup. The axis is now going to go off this face, still at that location, and maybe this guy is now 56, just making life easy, right? So again, you could say setup 3, 3-axis table. And then setup 4 would be 4th axis flat, and then 4th axis vertical, right? Oh, and undo that. There we go. Hey, Matt, great to see you in chat. So as you're seeing, Jeff, I'm wondering, is this kind of what you're looking for? Because the idea is there that, boom, setup 1, setup 2 is now mounted horizontal in the machine. And in this case, I did the flat side first. And then setup 3 is also horizontally mounted, all working off more or less the same work offset, right? So again, the idea is with that 0-point system, and a trick to 0-point, if you didn't know, and this works really, really good, I did a video on doing tooling balls, but if you build a base plate with a tooling ball on it, you could then utilize wherever that location of the tooling ball is to pick up all of these locations. Very easy throughout this process. So again, we'll go ahead. Jeff, let me know if that serves anything up. Matt, I see you in chat. Do you have any questions? Anybody else have any questions out there? Don't know why, but my nose, like crazy. So again, for anybody wondering what we're doing, we're basically creating a 4th axis system. And it's a manual 4th axis, but it works really, really good because his true position of his part, although it is dependent on these quick interchange vices, they are extremely accurate at the end of the day. But he has found a way to quickly go from a 3-axis table setup for machining into a 4th axis position without ever unclamping his part. Again, looks like Jeff's happy. Looks like that's going to work out quite well for him. So again, guys, if you guys have any questions, let's pull up the ticket system. Make sure nobody's throwing in any tickets. I know my website portal, we're going to go ahead and refresh it. Everything on my end, I don't know if the mouse is stuck or what's going on. I got stuff moving all over. Again, we're going to go ahead and close out Jeff's ticket. Chat has slowed down. Looks like people are starting to fall off. Must have got the lunch buzzer, called back to the shop. With that, as you guys know, I'm going to start to wrap this up. But if you do have a question, throw it in chat. I'm happy to answer it still. But as you guys know, it's not what you know, it's who you know. You all know Fusion Phil over here at jitcadcam. With that being said, if you guys do have questions at any time, feel free to send us an email. feel free to send us your subscription information if you're in North America, that we can renew your licenses and get you moved over to us. And then you can deal with yours late on a Friday night, because I anticipate, let's see here, there's probably going to be a couple of my customers messaging me at about 8:30 for parts that were supposed to ship yesterday that didn't quite make it. But that's why we're here, guys, is to help you guys, help you learn, help you understand, help you make the changes that I've heard people go out on Facebook. Some guy charges them a bunch of money and then never delivers. That's why we are an Autodesk reseller, and that's why we got certified. So with that, guys, have a great weekend. Double check and chat. Last chance. Going once, going twice. CNC My Parts, what's going on, buddy? Great to see you out in chat. I'm glad to be here for you guys, and I can't wait to keep doing this. Also, I almost forgot. Guys, go get signed up for the notification on next Wednesday's video. I think you're going to have a blast with this. We got Toolpath 1. Get me a license of the Toolpath AI model, which I am very green to. I'm going to watch a 20-minute video, and we are going to give you the most unbiased version, what I think of it and where I think it's going to play it out. Full disclaimer, I'm not an expert. I haven't even touched it, I think 3 times at some of my customers. So that being said, join us next Wednesday so that I can show you guys my opinion of Toolpath's AI plugin. As well, you get a true opinion of a guy that gets to see everybody's machine shop and how it plays. So, as always, guys, have a great rest of your week. Jeff, thank you very much for the beers. I can't wait to go drink them. I will see you all next Wednesday, live from Productivity in Minneapolis, I believe. So have a good one.